All right. Hello, greatens. Welcome to another episode of Mr. Matlas's class. Anyway, today we're going to solve simultaneous equations. And now, I've got a question from Elena, and then he was asking me, okay, sir, how do we solve simultaneous equations if we are given a graph? And then, okay, I thought maybe the best thing I should do about that is actually record a video for you guys. Anyway, so this is what's supposed to happen. If you're given a question like this one, the one we have here on the board, let me stand aside so that you guys can see everything. All right, so now, this is what we have here. We have two lines on a graph, and then they have an intersection point. Now, the first equation, y equals to 2x plus 1. The second one, y equals to minus x minus 5. How do you solve an equation like this one? Well, simultaneous equations like this one. Well, this one is actually quite easy. You know what you do is, look at the point where they intersect, and that is the solution. So for this one, you don't necessarily have to do a lot. Just look at the point where they intersect. So here we go. If you look at here at this point, so right here, on the x-axis, minus 2, on the y-axis, minus 3. So the solution to this problem is actually quite easy. It's supposed to be x equals to minus 2, and then y equals to minus 3. So it's really quite easy. If ever you're given a simultaneous equation that looks like this one, then the only thing that you have to do is look at the intersection point. Can we prove this? Of course we can. So let us try to solve this the normal way. Well, we have y equals to 2x plus 1, and then our other equation is y equals to minus x minus 5. All right, so the method that I'm going to use here is substitution. Well, what you try to do here is this. Well, you look at the simplest equation, and then you try to solve it. Maybe x is equivalent to blah blah, or y is equivalent to blah blah. In this case, let's look at what we have. Both of them are already stating that y is equivalent to the first equation, y is equivalent to 2x plus 1. The other one is y is equivalent to minus x minus 5. So what we can do is this. We can do the following. This is our equation 1, and this is our equation 2. So what we can do is this. In equation 1, we substitute for y. So therefore, minus x minus 5 is equivalent to 2x plus 1. Then what we do again, we collect the like terms. We take minus x to the other side, and then we take plus 1 to the other side. And so therefore, minus 5, bringing 1 to the side, remember it's going to change the sign. Minus 1 is equivalent to 2x. We take minus x to the other side, is going to be plus x. Plus x. And so therefore, minus 6 is equivalent to 3x. And then we solve for x. Divide by 3, divide by 3. X is equivalent to minus 2, see, which is what we discovered over here. So what about y? In order for you to solve for y, what you need to do is you just need to substitute for x. You can substitute for x in equation 1 or in equation 2. Now I'm just going to take equation 2 because it's the easiest one. So y equals to minus x minus 5. Y equals to minus bracket minus 2 minus 5, and then plus 2 minus 5. This is equivalent to minus 3. So as you can see, for a question like this one, it's really easy to solve, because now the two equations or the two graphs intersect. The point where they intersect, that's where we are going to get our solution. And so therefore, if ever you're given a simultaneous equation in a form of graph, and then the two lines meet or intersect anyway, just know that the solution comes from where the 2 points meet. You can do that by you can give me the solution, but like this, you can just give me the points where they intersect. Thank you very much. Now, let's move on to our next problem. All right, so now, here's our next problem. We have two lines here. The first one, y equals to 2x plus 1. The second one, y equals to 2x minus 1. Notice something about these two lines. They are parallel. Now, since these two lines are parallel, then you cannot find a solution for these equations. That is, there is no solution to these problems. Can we prove it? Okay, let's see. Well, y equals to 2x plus 1. This is our first equation. And then y equals to 2x minus 1. This is our second equation. So let's try to solve it the same way we tried to solve the first one, by substitution. Well, let's see. In this case, two x minus 1 is equivalent to 2x plus 1. And then let's try to collect like terms. Now, if you take 1 to this side, then it's going to be positive. So what you have here is 2x and then equals to 2. Then when you take this one to the other side, it's going to be negative, minus 2x. Look at what we have here. Minus 2x is going to be 0. And then this is saying 0 is equivalent to 2, which is not the case. And so therefore, if you have two lines, y equals to 2x plus 1 and y is equivalent to 2x minus 1, and then the two lines are parallel, then you will not find any solution. So basically, the answer to this question is this: there is no solution to this problem. All right, let's move on to the last one. All right, now our next simultaneous equations problem looks like this. It's a over 2 plus b is equivalent to 4. The next equation, a over 4 minus b over 4 is equivalent to 1. Now again, we must solve for a and b. How do we solve for a and b in this case? Well, let's make sure that we remove the fraction first. So this one over 1 over 1. And then what we have here is 3 to 2 ones, 1 times a plus 2b equals to 8. All right, then the second one over 1. Oh, so basically we can say the next equation is a over 4 minus b over 4 is equivalent to 4 over 4, because 4 divided by 4 is still 1. And so therefore now that our equation looks like this, what is our next step? Let's see. Well, remember in the previous videos how we solved something like this. Now, the denominator is the same for a, the denominator is the same for this part of the equation. So we get rid of the denominator, or we just leave the denominator, because now if I multiply by 4 here and here and here, then all the 4's are going to cancel. If I multiply by 2, the 2 is going to cancel. So now we get rid of the denominator and we will focus on the numerator. Now what we have here is a plus 2b equals to 8. On the next equation, a minus b equals to 4. All right, So now that it's like this, let's try to solve it. Then remember, we have two methods that we can use, elimination or substitution. Well, for this one, for me, I can actually use substitution because it's going to be the easiest one, or even elimination. It doesn't matter. So let me come to my second equation, which is this one. So A is equivalent to 4 plus B. Then let me substitute for A over here. 4 plus B plus 2B is equivalent to 8. And so therefore what we have here, we have 3B is equivalent to 4, and then B is equivalent to 4 over 3. Alright? What about A? Now that you have this, then you can actually solve for A. Let's see how you can solve for A. Now, you have A plus 2B is equivalent to 8. And then you substitute for B in this equation. A plus 2, 4 over 3 equals to 8. And then what you have here is going to be A plus 8 over 3 is equivalent to 8. Now take this to the other side. You have A is equivalent to 8 minus 8 over 3. Now to make it easier for us, 24 over 3 minus 8 over 3. Then what you have here is 16 over 3. Now let's see if this is going to work. So your A here is 16 over 3, while your B is 4 over 3.